Good evening all. Welcome to the last part of our module 1. So in this lecture we will cover the components of a railway track, requirements and functions of the components, and the typical cross section of a railway track. And after this section we will have a quiz based on this first module. Hope all the topics that covered in the previous lectures are very familiar to you, and we will discuss the components and its functions in this lecture. So let's move on to the topics. So in this lecture we are going to discuss about the railroads, the components of those railroads. Railroads are the special tracks meant for the traffic or the movement of trains. Usually the railroads consist of two rails running parallel at a specified distance. The rails resting on the sleepers and the sleepers resting on the ballast together forms the railway track, and this railway track is otherwise known as the permanent way of rail transportation system. And we will look at what are the components of this rail transport system or the permanent way of a railway engineering. So the main components of the railway track are rails, sleepers, ballast and formation. Rails, sleepers, ballast and formation. And in this figure you can see these components and they are labeled. These two I sections, the two I sections are known as rails. These two I sections are known as rails, and through these rails the trains are moving, and these rails will help to transfer the load from the wheels or from the vehicle to the underplaced sleepers, and from the sleepers the load will be transferred to the ballast, and from the ballast the load will be transferred to the formation. So in this manner the load is transferring in a railway track. The load from the vehicle is transferred to the I sections or rails, and the load from the I sections are carried by the sleepers placed under those rails, and the load from the sleepers will be carried by the ballast, and the load from the ballast is transferred to the formation width. And we will look at in detail about these components from the next slide. So first we will look at what are these rails. These rails are generally unsymmetrical I sections. They are unsymmetrical I sections made of steel, and they are laid along two parallel lines over the sleepers. These I sections will be resting over the sleepers. The sleepers are generally made of concrete or something wood or metal, etc. And these rails are joined longitudinally by fish plates or by welding. This is very important, and you can expect these questions in the GATE exams or PSC exams, how these rails are joined on the sleepers. They are joined longitudinally by fish plates or by welding. And these rails provide a continuous and level surface for the trains to move. These will provide a continuous and level surface for trains to move. Usually the wheels will be in between these head of the I section, and it is moving like that. It will be moving in between these I sections. So the I section is divided into three parts: the head, web and foot. And you have to focus more on these parts later in this lecture. And now we can look at what are the functions of these rails. These rails act as girders and transmit load to a large area of formation through sleepers and ballast. It will transfer the load from the vehicle, from the train, to the ballast or the formation level. And it provides continuous, smooth and level surface for the movement of trains. Also, laterally guides the wheels of the trains. As I told, there will be a groove in the wheel of the train, and that groove will be fitted over these rails. So these rails will laterally guide the wheels of the trains. It should be an economic section consistent with strength, stiffness and durability. The head of the rails should have adequate depth to allow for vertical wear. So we already discussed that there will be three parts for the rails. What are they? The head, the web and the foot. So there should be enough depth for this head in order to hold the wheels of the train. The web should be sufficiently thick to withstand the stresses. The stresses will be more at the web portion, so we should provide enough thickness for the web portion. And the foot should have sufficient thickness to withstand vertical and horizontal forces. These are the main things that should be considered while selecting a proper rail eye section. So in detail you will study the properties of these eye sections in detail in design of steel structures, and you have already studied the properties that must have by an eye section in the engineering mechanics: the moment of inertia, the center of gravity, and the properties of symmetrical eye section and the properties of unsymmetrical eye sections and all. So based on those values, the moment of inertia values, we will select a suitable eye section for selecting which is suitable for to be fixed as a rail. And there should be some requirements. We cannot select all the steel sections for making the rail tracks. So there should be some requirements, and we will look at what all are the requirements of the rails. There should be proper composition of steel, and they should be manufactured by open hearth or duplex process. It should have high vertical stiffness to transmit loads, and it should be capable of withstanding lateral loads. So these can be achieved by providing large width of head and foot. The head must be sufficiently deep in order to hold the wheels of the train, and it provides flexural rigidity, and foot should be wide enough to ensure the safety from overturning. And bottom of the head and top of foot should be so shaped as to enable the fish plates to transmit the vertical load efficiently. So these all are the points that should be kept in mind while selecting an eye section as a rail track. And the other requirements are: the center of gravity of the rail section must lie approximately at mid height so that compressive stresses, maximum compressive stresses, will be equal to maximum tensile stress. So we know that it is an unsymmetrical eye section, and we have to calculate or we have to select a section such that its center of gravity should be at the middle of the section. And the relative distribution of material of rail in head, web and foot must be balanced. So we have to ensure that the material distribution is same all over the section, in the head, in the web as well as in the foot. Then only we can ensure the smooth transfer of loads. The fillet radii must be large to reduce the concentration of stresses. I hope you learned about the fillet radii and all in the DSS portion. So you all are familiar with the fillet radii. So the fillet radii must be large to reduce the concentration of stresses. The tensile strength of the rail piece should not be less than 72 kg per meter square. All these points should be kept in mind while selecting a eye section as a rail. The rail specimen should withstand the blow of falling test or tuck test as specified by Indian standards without any fracture. So it should satisfy these tests, or it should withstand these tests. Then only we can approve that eye section as a rail section. Next we will discuss about the sleepers. In the figure you can see the sleepers. Sleepers are generally concrete beams, pre-stressed concrete beams used to connect the rails with them or to fix the rails without any movement, and it will not allow the rails to move either in horizontal or in transverse vertical direction. And these sleepers will help to transfer the loads to the ballast provided below the sleepers. So generally, sleepers are the members laid transfers to the rail track on which the rails are supported and fixed to transfer the load from the rails to the ballast and the subgrade. So it will act as an intermediate between the rail and the ballast. So we have to transfer the loads. Then only we can ensure the safe movement or smooth movement of the train. So the load is carried by the sleepers and it is then transferred to the ballast and then to the formation level. So now we can look at what are the functions of these sleepers. These sleepers are used to hold rails to the correct gauge. We will discuss about the gauge in the next module. It helps to hold the rails in proper level. It is used to act as an elastic medium in between ballast and rails to absorb the energy. It is used to distribute load from rails to the index area of the ballast. And it is used to provide longitudinal and lateral stability of the permanent way on the whole. So these sleepers are generally used to fix the rails, and this fixture will enable the smooth movement of the train, or it ensures the smooth movement of train. Then these materials must meet certain requirements. Then only we can consider those materials as a good sleeper. So what are the requirements of a good sleeper? It should be economical. The first point is it should be economical, minimum possible initial and maintenance cost. The fittings should be such that they can be easily adjusted during maintenance operations, such as easy lifting, packing, removal and replacement. The weight of the sleepers should not be too heavy or excessively light. It should be in medium range. The design of sleepers should be such that the gauge alignment of track and levels of the rails can be easily adjusted and maintained. The sleeper design and spacing should be such as to facilitate easy removal and replacement of ballast. All these are based on the easy maintenance of the track. The next point, the insulation of rails should be such that they are not damaged during the packaging process. And at the last, an ideal sleeper should have an anti-sabotage and anti-theft qualities. Next we will discuss about the ballast. Ballast are granular materials, usually broken stone or brick, shingle or concrete, gravel or sand, placed and packed below and around the sleepers to transmit load from sleepers to the formation and at the same time allowing drainage of the track. So ballasts are generally stones placed below the sleepers, and it will help to transfer the load to the formation level, as well as it ensures a smooth drainage system in the railway track. Otherwise, it will cause water to be retained in between the rails, and they may cause the deterioration of those rails, and after a long time they may cause some rail accidents also. So these ballast ensures a proper drainage system. And now we will discuss about the functions of ballast. It transfers the load from the sleeper to the subgrade and then distributes it uniformly over a larger area of the formation. It holds the sleepers in position and prevents the lateral and longitudinal movement due to dynamic loads and vibrations of moving trains. It imparts some degree of elasticity to the track. It is very necessary that the track should be an elastic nature. It provides easy means of maintaining the correct levels of the two lines of a track and for correcting the track alignment. That is a main factor for the successful working of a railway track. the levels should be maintained properly while the movement of the train. It provides good drainage foundation immediately below the sleepers and helps to protect the top surface of the formation. This is achieved by providing coarse and rough aggregates with plenty of voids. Then requirements of a good ballast. It should be able to withstand hard packing without disintegrating. In other words, it should resist crushing under dynamic loads. While trains moving over these ballast or the rails, it can cause strong dynamic loads. So these dynamic loads can cause the breakage of ballast. So the ballast should withstand these dynamic loads. It should not make the track dusty or muddy due to the powdering under the dynamic wheel loads. It should allow for easy drainage with minimum soakage, and the void should be large enough to prevent capillarity action. I'm sorry for some mistakes, some spelling mistakes are there in the PPT. Extremely sorry for that. It should offer resistance to abrasion and weathering. The non-porous particles of ballast are usually more durable. It should not produce any byproducts after undergoing chemical reactions. The size of the stone ballast should be 5 cm for wooden sleepers, 4 cm for metal sleepers, and 2.5 cm for turnouts and crossovers. The ballast should be available in nearby quarries so that it reduces the cost of supply. It should also fulfill the requirements of quality, amount of traffic, life and maintenance cost. The materials should be easily workable. Next we will discuss about the formation or subgrade. It is a naturally occurring soil which is prepared to receive the ballast. The prepared flat surface for fixing the rail is known as formation. It supports the entire structure. The shape, it is provided in the shape of an embankment or a cutting. It will be either in the shape of embankment or in the form of a cutting. And the functions of this formation level. It provides a smooth and uniform bed for laying the track. It bears the loads transmitted to it from the moving load through the ballast. It facilitates drainage and it provides stability to the track. And now we will look at the general type of formation levels provided nowadays. And this figure showing a single line BG track. BG means broad gauge track in an embankment form. Embankment means filling type form. So the rails are there. This is a single line. So 2 rails are there and sleepers are provided below the rails and the ballast level, and then below the ballast level there is an embankment that is made up of soil, naturally available soil, and this is known as a single line permanent way. Single line permanent way for a broad gauge. So this is a typical cross section of a single line broad gauge track in an embankment. And in this figure you can see a double line broad gauge track in an embankment. So there will be 2 tracks, first one and this is second one. So there will be 2 tracks and the components are the same. There will be a sleeper, there will be a ballast level and an embankment below the ballast level. And this is a typical cross section of a single line broad gauge track in a cutting. Cutting means that will be in an excavation. So there will be 2 lines and 2 rails. Below that there will be a sleeper and a ballast. Then that will be placed over a strong soil. But in general this is below the normal ground surface. So you should be familiar with these 3 types of track systems. and we will discuss in detail about these about the design or the geometric design of these track systems in detail in the next module. So that's all with this module. Hope all the topics that we discussed in this module was okay with you. You can ask questions um, during the live sessions, and we will discuss more about these sessions or these topics in detail in the live sessions. So see you there. Watch these videos, and you have to revise all these topics in a timely basis, otherwise you may forget these terms. So you should be familiar with these terms throughout these subjects, throughout these 6 modules. So keep watching these videos. So see you in the live session. Thank you.